Okay, I'm starting this course on tropical cyclones. I'm going to use mainly this online book called Introduction to Tropical Meteorology by the COMET program under UCAR, the University's Corporation for Atmospheric Research in Boulder, Colorado. They have their own online education system where you can register and take these classes, but I'm offering it directly as podcast, so you can use it as you want. This is the image of Hurricane Isabel in 2003, September. We start with this nice picture of the traction intensity of tropical cyclones between 1851 and 2006. They've used whatever data is available. So these are the color schemes here: tropical depression, tropical storm, depends on wind speeds, as we will see. Category 1, 2, 3, 4, and 5 in the Saffir-Simpson hurricane intensity scale. And we know that hurricanes are here in the Atlantic. Here they are called typhoons, and there are different scales used. Here they are called cyclones in the Indian Ocean, and they have slightly different scales of intensity and categories and what they are called. And you can see that the cyclones don't form on the equator because they need a minimum level of rotation, and as you go to the equator, the rotational effect of the planet around its axis is zero. It's a linear motion. You have to step off, and then you have to get to a critical latitude to get a sufficient rotation for cyclones to form. In the southern hemisphere as well, Indian Ocean is quite active, and so is the Pacific. We'll see some examples, and you can see that the tropical Atlantic has had one cyclone, tropical cyclone, so it's not a very active region at all. This region obviously is intense, high categories in larger numbers compared to here, and the total numbers are larger as well. The other thing you notice is that here in the northeastern Pacific, the cyclones go off into the open ocean and hardly ever go back and hit land. And you can see the general direction of propagation here as well clearly. They are forming around here, and they are going towards the northwest generally, and then they veer off towards the high latitudes and become eastward. If they survive till then, often they can get dissipated, or they can hit land and then dissipate over land. And the same kind of tract occurs here on average. These are called steering winds, not a very clearly defined concept, as we will see, because the cyclone itself is powerful enough to change the winds, but nonetheless there is background winds. Here you can think of it as trade winds that are taking it westward, and then you hit the westerlies once you get here and you go eastward. Here the two oceans are smaller, so they don't have as much intensification, even though now in the last few years, from 2015 onwards, 16 onwards, number of cyclones is increasing, and they seem to be rapidly intensifying, and we will see later on what we mean by that. It's just a measure of how quickly the wind speeds become increase by a certain amount within 24 hours, like 55 kilometers per hour within 24 hours. Okay, so we will see that. And here the ocean in the north is also split into the Arabian Sea and the Bay of Bengal. We'll see later on the sea surface temperatures typically are warm wherever the cyclones and hurricanes form. I'll just use cyclones for now. And Bay of Bengal is warm, but Arabian Sea is colder, as we will see. Plus, during the June, July, August, September of the year, the monsoon is very strong, the summer monsoon, and has a very strong shear, vertical wind changes, which splits the season into the pre-monsoon and post-monsoon. We will see some details as we go on later. Okay. What else can I say here? Generally, these are considered part of the Earth's attempt to move energy from the tropics, where energy coming in from the sun is in excess of the energy going back out to space as long wave radiation. So short wave is coming in, long wave is going out. Whereas at the polar latitudes, you have more outgoing long wave and energy lost to space than the solar energy coming in. So you need to move energy constantly from the low latitudes to high latitudes so that the tropics don't keep getting warmer and warmer because of excess energy, and the poles don't keep getting colder and colder. So energy is being moved by the climate system, weather system, and tropical cyclones are argued to be part of that system as well. Okay, here is an example of the 2005 tropical cyclone Ingrid, and you can see it started at a tropical low, moves towards the east, and then recurves and goes back, changing its categories multiple times, and finally making landfall over here as tropical cyclone in category 1 and 2, and dissipates. And we will see later on that this region between New Guinea and Indonesia and Australia is very warm, very conducive to cyclones. Cyclones are basically picking up energy from the ocean and dissipating it in the atmosphere. We will see how that works and what other conditions are necessary for generating cyclones. So here is a nice satellite image which shows a tightly wound system around the eye. Cyclones are called cyclones because they are cyclonic systems around low pressure. They should rotate in the same direction as the Earth's axis in that hemisphere. So in the southern hemisphere here, the cyclonic circulation is clockwise, whereas in the northern hemisphere it is counterclockwise. Here is the GOVI radar base scan and cross sections, and again you see a clear eye formation and bands of rain that we will learn about more. So you need to bring moisture in to feed these bands to form convection, and the strongest convection happens around the eye wall, which you can see here. So the eye itself has very low pressure but clean, can see through it because it has subsiding air and clear air. So obviously subsiding air can warm, and part of the rapid intensification is that compression of adiabatic compression of subsiding air can feed convective instabilities and convection bursts and so on that rapidly accelerate the winds and the rainfall and the feedbacks. The name itself, cyclones, obviously Greek cyclos, which means rotating in the same direction as the planet. And the origin of the word hurricane is attributed to god Hurrikan, which means a god of storm and winds, I think. This is the artist's rendition. This is from Central South America Mayan concept. Whereas the word typhoon, there is a word tufan in Arabic, there are taifu in Chinese, gufu, taifu here, and Japanese also have something like, sorry about that, taifeng and chufeng. So I'm not sure I'm pronouncing it right, but nonetheless the origin of the name itself is debated, but it could have gone from the Greeks to the Arabs to the Chinese and back and forth and so on, but the concept has been around for many centuries, okay, if not longer, based on how old the cultures are. Here is another example, Joan, that originated in the tropical Atlantic, got to be a tropical storm, and then category 1 to 5 or so, and then crossed over into the Pacific and was essentially reorganized. So it got renamed as Miriam, and then went off and dissipated in the northeastern Pacific, which is the warm region here with lots of convection and a lot of cyclones, as we saw before. Okay, in the next podcast we will look at the scales, and as we will see Not only are the names different, but the scales are also different for historical reasons, but they continue to be carried forward. But since they are locally monitored, named, forecasted, and so on, it doesn't matter so much. Okay.